Okay, welcome back to CCCS203 Programming 2. Um, this video lecture is going to cover interfaces in Java, and we're going to take a look at these four questions. What is an interface? Why is an interface useful? How do you define an interface? And how do you use an interface? Now, about the first two, what is an interface? An interface is a class-like construct. It's a lot like a class that contains only constants and abstract methods. So in a way, it's very similar to abstract classes, which we've already used. But for the moment, think of an interface as a special type of abstract class, one that contains only abstract methods. All of its methods are abstract, and its member variables have to be constants. Okay, so it's even more special than an abstract class in a sense. Abstract classes have do contain abstract methods, but can also contain concrete methods. That is not the case in an interface. Why is an interface useful? Well, we can use an interface in order to specify behavior for objects um, that have some type of common behavior. And we'll look at a very good example today that should clarify why you might want to, or in what type of situation you might want to use an interface. So as an example, for example, a behavior of a class could be whether or not certain objects are edible. Edible meaning whether they're eatable for humans. Um, so this is the general, up here in the first box, we have the general syntax of how we code an interface. So make it public interface instead of class. We have the word interface over here, and then you give the name of the interface. And after that, first you give the constants in the interface, and after that, the method signatures. Only the signatures, because remember again, um, all methods of an interface are abstract. So as an example, um, you could have an interface called edible, and to keep it simple, we're not going to keep this one's not going to have any constants in here, and it has one method, one abstract method here. It's a public abstract method that returns a string, and the name of the method is how to eat. So like I said, an interface is treated like a special class in Java. You keep it in a separate file, just like you should keep every file in your project, every class in your project in a separate file. It compiles compiles as separate bytecode, just like for regular classes. Um, like an abstract class, you cannot create an instance of an interface using the new operator. But what you can do is uh, you can use it as a data type, just like we demoed and saw. Just we can use it as a data type, just like we can for an abstract class. Mm. Uh, so um, you already saw where we use the keyword interface. So if we're making an interface instead of a class, we don't say class, we use the interface keyword. Um, and to specify which class implements or, uh, that a certain interface, we use another keyword called implements. Uh, okay, so now that we have Uh, let's continue with this example interface edible, and let me describe a small project that we're going to do, that I'm going to show you right now. So let's say we have this UML diagram containing uh, a class called animal, a superclass animal, which has two subclasses, chicken and tiger. Um, we have another superclass called fruit, which has two subclasses, apple and orange. Now, animal and fruit are abstract classes, and we can tell by looking at the font. Animal and fruit are both in italics font. Okay. Now, if you want a more complete picture, animal and fruit are classes that we are going to create, abstract classes that we are going to create. The complete picture is something like this. So animal and fruit are extending the object class of Java. And what we are going to do is we're going to add an interface, this interface edible, uh, to our project. Um, Edible, again, you have to look at two things to know that this is an interface. First of all, the font is again italicized, just like for an abstract class, but then we might still mistake this for an abstract class. But the reason or the indicator that tells you that edible is an interface is that the arrows that connect classes to the edible interface are dotted. So if you have a dotted line going to a class in a UML class diagram uh, that is shown in italicized font, means that this is an interface. Okay. Okay, so let me switch over here and let me begin. So I'll hop back to this picture every now and then, uh, just so you know what we're doing. So let's begin with the basic structure. Actually, let's begin actually by adding this interface edible. Okay. 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 So start with something new. So we have a new project, week 12 underscore 12 underscore 4. And the first thing I'm going to do is I'm going to add a new interface. Now, usually we just go to new Java class, but this time we're adding an interface to this project. So select new Java interface and call this one edible. There you go, new file, edible.java, just like for classes. But this is a public interface called edible. And I'm just going to add that method that I showed you on the slide. Um, so, sorry. So I'm just going to copy this. Well, actually, it's nothing. It's just a method, how to eat, and I'm going to add that to a project over here. And there you go. So public abstract method that returns a string, and the name of the method is how to eat, and that's all our interface is. Remember, we're doing a deliberately small example. Um, okay, back to our full UML diagram. Okay, so let's begin with uh, the abstract superclasses. Let's begin with animal. Okay, all right. So let me add a new Java class, animal, and animal is going to be an abstract class. I have to add abstract keyword myself. Um, and I don't need to put anything in here, so I'm going to leave this like that. Um, the other abstract superclass is fruit, and like I said, this is abstract, and according to the figure I have over here, fruit will implement the edible interface. On the other side, among the animals, remember, a chicken is edible, but a tiger, no, we don't eat that. Uh, most people don't. So the animal class, superclass, is not implementing the edible interface on this side. But over here, the abstract class fruit is. Okay. So I have to add something else. Implements edible. That's it. This is how you declare that one of your classes is implementing an interface. In this case, the interface is the interface edible. Okay, let's continue. And let me add chicken, tiger, apple, and orange classes. Okay, let's go back. Let's add class called chicken. There you go. And because this is so this is a extending animal, and animal implements edible. So now I have to make sure I add a public method that returns a string called how to eat, and I have to do something in here. This one, I'm going to keep this very simple. It returns a string, um, and the string is going to be chicken. Fry it, all back style. You all like that. Okay. Okay, we're done. We're done implementing the um, edible interface for the chicken class, uh, which is a subclass of animal. Okay. Next is the tiger class, which also extends animal, but because oh, hold on a second. Actually, I'm sorry. So, tiger extends animal, but is not edible. Let me just missed something about the chicken. So chicken is actually not inheriting the edible interface from animal. It's implementing it directly. So I have to go back here and fix something. So in the chicken class, extends animal, implements edible. There you go. How to eat lights up. Okay. Yep. All right. All right. Uh, let's move on to the apple class. So let's add a new class called apple, and apple extends fruit, and fruit implements edible. So I need to put in public method that returns a string called how to eat, no arguments, and this will return something like the how to eat method. So apple, make apple cider, and we're done. And finally, we have to make a class orange, capital O, and orange is also a subclass of fruit, and remember, fruit implements the edible interface, which means orange needs to have a public method that returns a string called how to eat that takes no argument, and it too will simply return a string saying orange, make make orange juice. There you go. I think we're done. So as you can see, this pane over here, can be a little proud of yourself if you're following along. Now have a project with a decent number of classes. But we're not doing anything in the main method yet. So let's change that. So let me make an array of objects, all kinds of objects, obj, and let me initialize it right here. There's going to be one tiger in there. There's going to be a chicken in there. There's going to be an apple object, and let's also put in an orange object. Okay, so we got that. Let's now go through all of these in a loop. Int I0, and this loop will go for as long as the number of elements in the array obj. Okay, and inside it I'm going to have an if condition, and if the object implements the edible interface, I want to call the how to eat method. So how am I going to do that? I'll have an if statement. So if the object I'm looking at, object I, is an instance of edible. So you can see you can use the instance of operator this for an interface the same way you could use it for any other class. So if the object in the loop that I'm going through, in which I'm going through each element in this array obj, if the instance implements the edible interface, what do I want to do then? I want to print out system.out.println. I want to print out the string that I get from calling the how to eat method. So let's do this step by step. So object I, I'm going to call the how to eat method on that. But if I do that, if I do it like this, I'll have a problem. Let me show you. Erroneous tree type. Okay. So remember, this array contains objects. When I'm calling how to eat over here, Java has no idea what to do with that because it's considering this a reference to an object. Not every object has the how to eat method. So, which means before I call the how to eat method, I have to cast this object, which we've done before. It's not new. So I have to tell Java, you know what, this is of type, this implements the edible interface. As you can see, as soon as I did that, how to eat went from italics to the regular font, which means the compiler now knows what how to eat method I'm talking about. Okay, so when I run this and I go through these 4 elements in the array, the first one, tiger, is not edible. So I will not go into this if condition. But chicken, apple, and orange are edible. So and have how to eat methods. So those 3 how to eat methods will be called. So I should see 3 lines in the output. Let's see. There you go. Chicken, fry it Albec style. Apple, make apple cider. And orange, make orange juice. And that's it. That's a demo for a simple demonstration of how you can use an interface, in this case the edible interface, and how you can implement that interface in abstract superclasses, and how the methods of the edible interface then have to be implemented at the in the subclasses, apple and orange, of which we can actually make instances. And we can also see how we can bypass superclasses and just have subclasses somewhere at the lower level that have to implement the edible interface. So there's no rigid structure um, into which an interface has to fit in. Okay. Uh, all right. One thing that we skipped was a member variable for the edible interface. Actually, I think I can just add that right now just to show you. Um, so I can add a public static final member variable. I don't know, I'll call it food, final integer called food. I don't know why. There you go. I can still compile all of this and it'll still work. So this is how you add uh, a static variable in interface. All variables, all member variables you add in an interface have to be public, static, and final. They can be double, can be strings, can be anything, but they have to be public, static, and final. All right. Okay. So this is a neat table that explains the difference between interfaces and abstract classes. Take a look at this. So abstract classes, no restrictions on uh, what types of variables you put in. It can be public, can be private. In interfaces, they must all be public static final, which means they're all just shared constants. Shared between, well, they're just constants. Um, about the constructors, interfaces do not have constructors because you do not make objects. You cannot make objects or instances of interfaces. Um, abstract classes have constructors, can have constructors, and they will be invoked by subclasses when you make an object of those subclasses, an instance. Um, about methods, so abstract classes have no restrictions. You can have all concrete methods. You can have um, all abstract methods. You can have a mix. It all works. It's all okay for abstract classes. Remember, we have all concrete methods for an abstract class. That means that you are not able to create an instance or object of that class. So that's the purpose of having an abstract class without abstract methods. For interfaces, all methods must be public and abstract, which means no code in any interface method signature. Uh, so all classes share a single root, the object class, but there's no single root for interfaces. So like class, an interface also defines a type. Um, we haven't seen that, but a variable of an interface type can reference any instance of the class that implements the interface. Uh, if a class implements an interface, the interface becomes kind of like a superclass for that class. And you can use an interface as a data type. And here's another example I want to show you. So let's say we have some abstract class, class 1, which has a subclass, class 2. And let's say that abstract class, class 1, it's kind of at the top. It's just it's directly extending Java's object class. You could have uh, one class implementing multiple interfaces, and you can even have interfaces implementing other interfaces, like this interface 1 over here implementing interface 1 underscore 1 and interface 1 underscore 2. So that's all okay. It can do all of that stuff. On occasion, however, if you have a single class implementing too many interfaces, you might run into conflicts. For example, may have two interfaces with the same constant but different values attached to them. Um, these kinds of errors will be caught by your compiler, so you'll know what's going on. Um, Usually, when there's a strong relationship between two classes, we make the relationship between them one of a superclass and subclass, a parent class and child class, like we've been doing for so long. So, like animal and chicken, animal and tiger. That's a strong. That's what we consider a strong relationship between classes. But where the relationship is more is weaker, where we say that oh, this class is kind of another of another class, where the relationship is weaker. That's where might want to uh, model that relationship using an interface. So, for example, a fruit is a kind of uh, or let's say a tiger and chicken are they're both animals, sure, um, but go back to that example. Um, if I now want to have a how to eat method, it's not possible to put that into another superclass in between the animal, fruit, and object methods. It's not possible to put that up here. Um, so that's why we have an interface, because the interface can um, be implemented by superclasses, which will then make all their subclasses implement those methods, or can also be implemented selectively by certain subclasses of superclasses. Okay, so strong relationships means usually we try to model things by a superclass subclass relationship. For weaker relationships, uh, we uh, we just go with using an interface. So, like I said, in Java, interfaces are used to share common behaviors. Um, if you want to share common code, then again, interfaces contain no code, only method names. If you want to share code between classes, you need to have a superclass subclass relationship. And that's all about interfaces. And next, we'll talk about um, processing primitive data types as objects, but that's for next time.